Hello. So here I need to check that both sides of the identity are indeed equal for the given values of the variable t. Notice cosine is an even function. Even function. So if we have pi over 6 radians is this interior angle, and if we have negative pi over 6 is this interior angle, notice that the cosine is the same for both of them. So this top one, this is cosine of positive t. This bottom one is cosine of negative t. Your interior reference angle is the same. Your x value goes over the same distance on both of them. And so cosine of negative pi over 6 is going to be radical 3 over 2. And cosine of positive pi over 6 is also going to be radical 3 over 2. They are the same value. Similarly, with the negative 5 pi over 3, so if we were to add 6 pi over 3 to this, adding 6 pi over 3 turns this into pi over 3. Okay, pi over 3 is going to be like a 60-degree angle up and down. Okay, and cosine of negative 60 degrees is going to be 1/2. Cosine of positive 60 degrees is also going to be 1/2. 1/2 is equal to 1/2. Okay, cosine is an even function, so cosine of negative, whatever your angle is, going to equal cosine of positive, whatever that angle is. Tangent is an odd function. We'll see this here. So let's convert this into let's add 6 pi over 3. So this is the same thing as which is 120 degrees. So we're going to compare tangent of negative 120 degrees to negative tangent of positive 120 degrees. Okay. Thirty, 69. Let me make this bigger. So 120 degrees is going to be 90 plus 30. And negative 120 degrees is going to look like Okay. So that tangent of negative 120 is going to be radical 3. And negative tangent of 120 degrees is going to be radical 3, but a negative radical 3. Negative times a negative is a positive. Maybe you can see this point here is your sine over your cosine. And so whether it's this point where you have negative sine over cosine, or you have this point where it's positive sine over cosine, the end result will be the same. Pi over 4 is going to be 1. I'm sorry, tangent of pi over 4 is 1. Tangent of negative pi over 4 So that tangent of negative pi over 4 is dealing with this point here. So this point here would be negative 1. And this is going to be tangent 45 degrees. This is positive 1. And then we're going to apply the negative to that. You see that negative 1 is indeed equal to negative 1. Okay. Adding 2 pi to this is the same thing as pi over 3. So cosine of pi over 3 is 1/2. And cosine of pi over 3 is 1/2. They are the same value. Same thing with t is pi. So what we're looking at is cosine of 3 pi is equal to cosine of pi. So if we look at our axes, and we see that this is 1 pi, 2 pi, 3 pi. So that point is at 3 pi. And that point is at cosine of pi. They have to be the same value. Negative 1 equals negative 1. How about a proof that the equations are identities? So this gets into the area of 47 through 54. And on these, I would recommend breaking it all up into sines and cosines and adding fractions with similar denominators. Okay, so we have the left-hand side. LHS stands for left-hand side, and RHS stands for the right-hand side. So left-hand side, let's make this into sines and cosines. We have that's the numerator. and that's the denominator. So this fraction is missing a cosine, so we can change this into, we can multiply this by cosine over cosine. Same trick down here, if we can multiply this by cosine over cosine. So just looking at the left-hand side, this is equal to all of this. And then when you're adding fractions, have the same denominators, add the numerators. Subtracting fractions, same thing, same denominators, subtract the numerators. So we have this configuration. Multiply all of this by the same non-zero number divided by itself. Say cosine theta over 1 all over cosine theta over 1. What this will do is the cosines will simplify, and the left-hand side is simply so that's the left-hand side. Hopefully we can make the right-hand side look like this. So the right-hand side is secant squared plus 2 times tangent, but tangent is sine over cosine, and then the whole denominator is so we have secant squared, which is 1 over cosine squared, plus 2 times tangent theta. Well, tangent theta is sine over cosine. The denominator, we have 2 minus, and secant squared is 1 over cosine squared. Okay. So let's multiply all of this by same non-zero number divided by itself. Okay. What this would give me is, the first simplify gives me just a 1. And then plus, this would be 1 cosine simplifies from the numerator and the denominator. So this is, and then for the denominator, we have all right, let's see where this goes. This cosine squared is sine squared minus 1. I'm sorry, 1 minus sine squared. So I'm not seeing where the right-hand side is going, so let's play with the left-hand side. Let's clean this up a little bit here. This is our right-hand side. Two minus one is one. What if we were to multiply this by same non-zero number divided by itself? This is the difference of squares in the denominator, and we'll do something in the numerator. Okay. Now, note cosine squared plus sine squared is equal to 1. And in the denominator, so I'm wanting these to look the same. So I'm steering the left-hand side to look like the right-hand side. The numerator looks good. The denominator has a sine squared. So let's turn this cosine into a sine squared, and hopefully this will, the left-hand side, hopefully the left-hand side will turn into the right-hand side. So this is going to be and we have it. Since the left-hand side is equal to the right-hand side, these are equal to each other. Thank you very much. Please go to tutoring.